I just need to get rid of a couple housekeeping items and then I'll give it right to you. I don't plan on taking very long. All right, it's 10:01, so let's get started. And good morning, everyone. Welcome to the Friday session for the 2021 MN GIS LIS conference. So this session is going to be split into 3 different presentations. Each presentation is going to be 25 minutes long, with a 5-minute Q&A session at the end. I encourage you to, whenever you come up with a question, to just put it in the Q&A box, and that can be found by clicking the Q&A button at the bottom of your Zoom panel. And then I want to give as much time to my presenters as possible. So without further ado, I'm going to introduce the first presenters, Chelbi and Alex, as they will be discussing water demand in the Southwest, municipal water usage with ESRI dashboards. Thank you. You guys can start whenever now.
Sorry about that. Can everybody hear me okay?
Hear you pretty well.
Thank you. All right, well, good morning, everyone. Thank you for attending this session on municipal water usage with ESRI dashboards. I'm Chelbi Stromblad, and I'm a GIS analyst with EHS Support. The EHS GIS team recently partnered with the city of Flagstaff in Arizona, a mid-sized city in the Southwest, to develop a water use management operations dashboard. If you've been watching the news, I am sure you've heard about the water shortages affecting the Southwest. The goal was to allow the city to make more informed decisions about future development scenarios that they had in the works. As demand for water continues to rise, the need for effective, forward-thinking water use planning has never been more important. We'll go over the process of data acquisition and normalization, along with the creation and use of the final dashboard tool. We'll end with a little demo of the tool and time for questions. So before we get into the creation of the tool, we should first evaluate some of the problems Flagstaff was having with their existing setup. The data used in the project was kept in several different locations in several different departments. Some data was already spatial and digital, like the zoning information and parcel data, but some was not, like the water use meter data and the billing data. The meter data had addresses listed, but only for purposes of billing. If the city wanted to find out which preferred growth scenario place type a specific meter fell in, they would have to open the tabular data, punch the address into Google, get coordinates, and then have the GIS department overlay that on the regional plan zones from the planning department. As you can tell, this was a cumbersome and inefficient process for even a handful of meters. Flagstaff wanted all of this information in one place so that the non-spatial metering data could be connected with the zoning and other related data. As we'll see later in the presentation, having all of the information together allowed the city to revise their water demand analysis to one that was more in line with actual current and projected usage. Normalizing all the data would be very important to the accuracy of these calculations. But to get started, EHS Support had to gather all necessary data. A large portion of the City of Flagstaff spatial files were located on their open data portal. For the files not openly available, we used Microsoft's OneDrive to transfer files. Getting a copy of the usage database was a larger endeavor. With the size of the database, we chose to have a flash drive mailed. Sometimes it takes more time trying to get an FTP working than it would cost to overnight a flash drive or hard drive. We collected over 40 spatial and non-spatial files that pertain to the project, along with a replica of the water use database. With nearly 400 tables in that database, we also requested documentation for the schema so that we were able to navigate through it. Now that we had a copy of the database, we needed to access it. After restoring it locally, we had to learn how that database actually worked and how things are tied together within it. The documentation of the schema included all of the tables, the fields within them, and how they are connected. Our translation of how to get from the meters to adding relevant information like the readings with consumption, account information, and general locations is what you see down below. Using this path, we were able to put together queries to pull out this information so that it could be reviewed and used later on in the process. Altogether, this included almost 850,000 meter readings, the meters, and the accounts associated with those readings. Prior to using the collected data, we wanted to make sure that everything was correct and usable. Throughout the review process, we had discovered some issues that would affect the end product. Originally, Flagstaff planned to use their 2030 regional land use plan to categorize meters for the water demand analysis. The land use files that we received were not quite down to the parcel level of data yet, which revealed address points that were not covered by a land use category. Conversations with the city staff led us to using the preferred growth scenario put together by the planning department for the analysis instead. Although we reviewed numerous other data files, the main focus was the water use database, as this data will be used not only for consumption summaries, but also for the water demand analysis. After pulling the relevant information, we had found missing service IDs. These service IDs aid in connecting tables within the database. So without them, those data entries would be left out of the data set. We discussed this with the city staff and mutually decided that those missing IDs were associated with accounts that had been issued a new ID number over time, meaning they were defunct accounts, which allowed us to move forward. We had also found a couple of issues that would make finding the meter locations a little more difficult. They had missing addresses and parcel IDs. There were also meter numbers that were used more than once in more than one location. These meter numbers are what we were using as a unique identifier for the future product. So with the same meter number, this causes that meter to only be tied to one account rather than the multiple accounts that it should actually be tied to. After bringing this issue to the city of Flagstaff, we had learned that these meter numbers were put in as placeholders. So as these meters, like the meters were unknown at the time of the data entry. So in the future, these meters would be given a unique number to make them stand out from each other. Using available information within the database, along with working closely with the city, EHS was able to locate 24,712 meters within the city of Flagstaff's urban growth boundary. This also includes the meters mentioned previously that were missing key data. For locating the meters with missing or incorrect parcel and address information, we utilized the county's parcel viewer to locate meters based off of parcel ownership and tax addresses. In the end, we were left with 152 unlocated meters, which all in all, that's a pretty small percentage. Most of these were unable to be located due to incorrect or lack of information in the database. The city is aware that some locations are going to be found in the future by staff. Now that we had collected the relevant data, reviewed it, and located it, we were able to consolidate the data into one central location. The files are now housed together within a geodatabase. Those files include the meter locations, readings, categorized parcels, along with the base layers that will be used in the tool. Outside of the geodatabase, there are also files for the water demand analysis. This analysis was done using data from a 3-year period, as this was the data that the city was most comfortable with as far as accuracy. EHS worked closely with a representative of the city and came up with maximum water demands at current occupancy, committed water needs, and projected water needs. All of this data is now housed on the city's ESRI portal, where it can easily be accessed by city staff. With our new geodatabase in place, along with the water demand information, we were able to develop the City of Flagstaff's water demand dashboard. What you see here is the overall dashboard. As you can see, there are many parts to it. We have an interactive map with filter options, along with interactive and static charts. Next, I'm going to break down the sections so that we can have a deeper look. The map houses relevant data layers that can be turned on or off within the map, depending on the user's needs. This allows for exploration of the data in a visual environment. This is something completely new, as the meter locations were not displayed spatially with their reading and consumption information prior to this project. Having and on the dashboard is something that was very important. Currently, Flagstaff automatically updates information on a variety of their web-based ESRI products. And because this dashboard is housed in the same place as those products, there was already a form of automation happening that just needed to be fine-tuned. EHS supplied the city's GIS department with the appropriate files so that this data can be automatically updated on a schedule of their choosing. With close to 1 million meter readings, it's good to know how to filter down the data. We have supplied the user with multiple ways of doing this. So first, in the top right corner, there's a magnifying glass. This is the search option. You're able to enter a meter number or an address, and the map will pan to that location. On the top of the web map, there are also other filters. You can enter a date range, which will limit your meter reading information. You can also select a neighborhood. The map will then pan to that location, as well as limiting the meters and meter readings only to that neighborhood. The data is also filtered based on the extent of the map. In the bottom right-hand corner, you can zoom in and out within the map. You can do this with using your scroll wheel too. You are also able to move around in the map by clicking and dragging, which will change the data being shown. Lastly, you can select a specific meter or multiple meters by using the select tool in the upper left-hand corner of the map. For privacy reasons, we are using a Flagstaff member's meter here and throughout the remainder of the presentation with their permission. But we have also removed the meter numbers to be extra cautious. All of these techniques will filter the data within the map while also filtering the data shown on the interactive charts that we will talk about next. These are the interactive charts focused on the total consumption. This is broken down into 5 categories, but we will start with the first one. As I mentioned before, the city decided to categorize their consumption for their water demand analysis based on their preferred growth scenario. Similar to land use, this scenario contains a variety of place types that refer to the purpose of the land. Each parcel and meter within the web map contains a place type from this scenario. The consumptions are summarized by these types and will appear in the graph below. The user also has the ability to hover over each bar on the graph to see the total gallons consumed. Under the interactive charts, there's also a key for the place type abbreviations. The next tab within the total consumption is the zoning. As with the place types in the previous slide, the parcels and meters are also assigned a zoning designation. And you can see the total consumption used by each category. Although this was not something previously used for water demand analysis at the city, it is something that the city thought would be helpful for decision making. Another breakdown of the data is the rate schedule. The rate schedule comes from the city's water use database and is how the meters are actually billed. So just because a meter falls within a residential place type, that doesn't mean that there cannot be some locally owned shops in the area that are billed as commercial. This also allows users to see more of a breakdown of the residential place types in general, as far as consumption differences between single and multifamily housing. The consumption is also broken down by neighborhood. This can be used to identify which neighborhoods are using the most water or the least. While this is, this can be from a lack of meters though, like if the water consumption is low, or it can be from open space that can potentially be built on. With that being said, in the future, Flagstaff would like to add projected and committed demands to this as well. Lastly, the total consumption can also be shown per meter. Right now, there's a limit on how many can be shown at a time, because if we showed every visible meter, there would be no way of reading them clearly. This is a good interactive chart for utilizing your select tool within the map. If you select a single meter or multiple, those will be the meters that appear here in this chart. In the future, for all the interactive charts, the city also plans to add average or median consumptions per category. As I mentioned earlier, there are also files for the water demand analysis that are not directly tied to individual meters. We have created static charts to reflect the data shown in those files. Here you will see the maximum water demand at current occupancy. This is based on the current infrastructure at the absolute maximum population density, along with the apportionment between residential, as shown in the left graph, and commercial, as shown on the right. We have also included the total acre feet for each category over to the left to make things a little easier. As using the preferred growth scenario for water demands is a new process for the city, these residential totals alerted them to look deeper into the current density calculations within the scenario and if they are actually appropriate for the water demand. We have also created a static chart for the committed water needs. These needs are based on future infrastructure and, again, the apportionment between residential and commercial. For the future infrastructure, we utilize Flagstaff's building permits. So if the parcel had an active building permit, it was added to the committed water needs. In addition to the total acre feet, we have also provided the total acreage of the properties on the left-hand side of your screen. Similar to the previous chart, we have also provided the projected water needs. These needs are based on the potential future infrastructure and are grouped by residential or commercial properties. For potential future infrastructure, we utilize the assessor information to find the vacant parcels within the city's urban growth boundary. One thing to mention, for these committed and projected water needs, you can also find the categorized parcels in the web map that I showed you earlier. In the future, Flagstaff would like to break down the place types further by also including the billing categories. These categories are not yet spatial, so for now we have provided pie charts. As I mentioned earlier, within each place type, there are multiple uses that are reflected within the billing system. As you can see in these examples, industrial heavy consists of manufacturing, commercial, as well as landscaping. We have included percentages for the categories, and you can also hover over each slice to see the actual total consumption over the same time period of the demand analysis. Now that I've shown you around the dashboard, let's look at some examples of how to use it. So as I mentioned earlier, there are many ways to filter your data. One of which is just scrolling around in here. As you move your map, the charts to the left are actually going to change. But let's look at an actual example. So we would like to look at the gallons consumed in 2020 by the Pine Park Manor neighborhood. So first what I'm going to do is zoom out because Are you guys hearing this video?
Select your neighborhoods. They do have to be in view. Then I'm going to go over here and I'm going to change my date range. I had it as 2020 already, but I will make it full year. And then we're going to go over to our neighborhood. I said Hyde Park Manor, so we'll type that in. So it's going to zoom us to the neighborhood. You're going to see a blue highlight around it, and it's only going to show the meters within that neighborhood. So if we go over to the place type tab, we will see that this UMR consumed the most gallons. Looks like 908,097 right up there. And if we want to figure out what this UMR is, we're going to come down here to this abbreviation key with the place types, and it looks like it's urban mixed use residential. And then we also have this little guy down here, which I believe is suburban neighborhoods at 9,700-ish. So after finding this out, we can then go back to the neighborhood filter and clear it out by selecting none. I'm gonna zoom you completely out. And we will look at a different category. So how about for this one, we will look at the billing category, also known as the rate schedule, that consumed the most water in downtown Flagstaff from 2019 to 2020. So once again, we'll utilize the date range neighborhood filters. So I will switch this over to 2019. And we said downtown Flagstaff. Once again, you get that blue highlight. And so this time we're looking at this rate schedule tab. So I'm gonna arrow over here. And it looks like commercial is the billing category consuming the most water in the area from 2019 to 2020. Makes sense, you know, think of all the little shops that probably exist in a downtown area. We can also select some of these meters. Take a look at maybe the zoning that they fall into. We'll hit this meter location. That's what we want.
You have 5 minutes left.
So if we go to the zoning regulation tab, we see the CB, and within this abbreviation key, there's also the zoning if you just arrow over, and it looks like CB is central business. So once again, makes sense, downtown area, kind of goes along with those shops. So another thing to look at with the subset of meters is to look at them individually. So with these ones that we have selected, we can go over to this per meter tab. And normally we will have the meter numbers and gallons consumed, but for privacy reasons, we left them off. But kind of nice to see, especially if you work for the city, to see who's using the most and who's using the least. Some other important things to keep in mind are the static charts on the bottom of the screen that include the water demand analysis I mentioned earlier. The demand numbers are all contained within these 3 tabs down here. And then while the further breakdown of the place types are over to the right here, if you click on the place type, you can navigate to the one that you're looking for. So go to Metropolitan Core, and I mentioned this before, but couldn't really show you. If you hover over them, you can get the actual gallons that were consumed over that same 3-year period that this demand analysis was done.
So all in all, for success in any project moving forward, or for anyone thinking of doing something similar, we have identified some things to think about. You want to make sure you have a game plan from the start. This means knowing what you want to achieve, knowing the data you want used, and knowing if this is something that will be used only internally or if the public will be viewing it as well. You want to make sure you know your data and how to get it. The better your data sets are, the better your product's going to be. If your data is not initially tied to spatial locations, like in this case, there's almost always a way that it can be. You also want to know the faults in your data. A review process is always great, but if you know the problems up front, it can save you a lot of time. You want to think about the future, think about storage, how you want to see your data, think of it something you would need to have near real-time data for, and if you're able to automate that. Also think about how you plan to maintain it. With the maintenance, it's always good to consider your hosting needs. In the case of this project, the city chose to host the data themselves with the potential for us to maintain it in the future, but it was also an option to have us maintain it from the start. Dashboards are useful for more than just water resources. I think everyone is familiar with the various COVID-19 dashboards used more recently. We also use dashboards for monitoring lab analytical data at various sites within the US and internationally. Imagine something like this dashboard, but instead of water use data, we have historical concentrations of various chemicals of concern, and those are usually charted against several other factors. One of the biggest benefits here is that it puts the power to interrogate the data in the hands of the client. This allows for a lot more flexibility for decision making and also decreases the burden on the GIS department and having to create static maps and figures for data exploration. When you spend less time making maps, you have more time for the fun stuff. That concludes this section of the presentation. I have my contact info on this slide if you have questions after the conference, and I'll also be happy to take the questions you have now.
Doesn't look like there are any initial questions at the moment. So I kind of wanted to take a quick second to ask. Did you guys do any field work at all? So did you send anybody out to go collect any data physically?
We did not. This was based off of data that they had already collected, but it did trigger a lot of field data, especially with some of the meters, like not having all the information in the database. So there were a couple meters that some of like the workers actually knew where they were and had to go locate them.
Cool. And this was just meter data. You guys didn't have like water line data or anything like that?
Nope. I think that is part of something that they do want to expand on this dashboard, and that is something that was mentioned for later on.
Cool. All right. It doesn't look like anyone else has any more questions. Oh, wait, we got one. So Jonathan Brasky asks, where is your company out of? Do you work in Minnesota?
Oh, that's a good question. So our company is fully remote. It has been from the start. So we have people from all over the place. We have people in Australia. We have people all over the US. I think we have some in the UK. I personally work, I'm kind of over by Superior in Wisconsin.
Good practical dashboard. Yeah. Nice,
Oh,
easy, to the point.
Well, thank you guys.
All right. That's the case then. We'll move on to the next presenter. Thank you very much, Chelbi. So then now Damon and Bob are going to be presenting on Minnesota's groundbreaking project, Underground Utilities Mapping Project. The floor is yours.
Getting there. All right. Moderator, you see my screen good?
Yes, sir.
Perfect. Just moving things around. All right. So my name is Damon. With GIS manager of a construction contractor company out of Southern Minnesota at Ellingson Companies. Mr. Bob there is also on our team. He's involved with the city of St. Paul and about 20 other endeavors. But I'm going to get going here because we got a lot of content, relative small amount of time. So let's get on here. All right. So as shown on the screen here, we're here to talk about underground utility mapping project team. And I got 5 different parts that we're going to talk about during this presentation. First of all is, what's the problem? What are we here to talk about? Secondly is I'm going to talk about the collaborative effort that has come together to address the problem, which is the underground utility mapping project team. Followed by, we'll begin to scope things down by talking about one of the elements of underground infrastructure, which is pipeline threats. And I'll zero in a little bit more on the focus of Minnesota pipes. And finally, I'll discuss the plan that you guys can understand how we anticipate moving forward and where we've been a little bit up until this point. So every year, more and more stuff is getting buried. In the upper left view, you can see how bad things were in New York City over 100 years ago. Today, when I'm left wondering why it's taking construction crews so long to finish the rework of some of the streets in Minneapolis, all I need to do is reflect on this picture in the right upper hand corner. There's a lot of stuff going on. If we drop down and look at the left and the middle boxes on the bottom part of the screen, we can see some of the categories of stuff beneath our feet, items which have been added to year after year and will continue going forward. Cable and fiber being the newest additions to the party. And because of this, things are continuously being added and underground infrastructure ages out due to natural deterioration. I don't know the definitive age expectancy of wood, but I know cast, as you can see behind me, it does not last forever. So surely in this day and age, we're all using super highly accurate maps, technologies like virtual and augmented reality to ensure that every best possible understanding and location of underground utilities is known about before we go out and dig. Regrettably, the answer is a sympathetic no. The reality is that nationwide, we do not have a comprehensive know of what's underground. Both the what and the where element are lacking. Consequently, there have been an ongoing nationwide problem of construction damage to all types of underground utilities. 2019 estimated damage was over $30 billion, with an increase over the 5th straight year. In Minnesota, the response to this issue was the creation of Gopher State One Call in 1987, after a construction crew hit a gas pipeline in Mounds View, resulting in the death of a mother and her child. Functionally, Gopher State One Call now serves as our 811 or call before you dig function for the entire state. And although Minnesota is considered one of the best states in the union for damage prevention, things are less than perfect 30 years after Gopher State One came into existence. In 2019, the last year for which we have complete numbers, our best guess is that there were 4,300 hits on buried utilities in Minnesota. Of these hits, the top category was natural gas with approximately 2,000 hits. Against the backdrop of all this ongoing damage, the problem has been heightened by the demand for locating services. An example, on any given normal day, Monday, June 22nd, 2020, Gopher State One Call handled about 7,000 calls for locates. This is a monumental task, given that the law requires that these requests be marked within 48 hours, and then they're only good for 2 weeks. Finally, while the locating situation has been increasing and developing as just described, the GIS and GPS technology have been rapidly evolving. But Implementation of this technology has not kept pace in the underground utility sector. The United States is often and well behind Europe on mapping underground infrastructure. And although Minnesota is rated a top prevention state, the greater Gopher State 1 community understands there's a large gap in tech and lag in technology and wants to leverage GIS to improve the efficiency and the safety. So how do we find what's there, huh? Without accurate understanding of what's under our feet, the process being used today is pretty much what it was when Gopher State 1 call started in 1987. After a locate request comes to Gopher State 1, it coordinates with the local utilities to have their infrastructure marked at the requested address. To do that, the utility sends out a locating crew, which uses the process depicted in the slide in the upper left-hand corner of the screen. So, spray paint. Using a handheld can that senses changes in the magnetic field, an individual traces that utility underground and marks it with the spray paint, and then places the appropriately colored flags. As you can see in the upper right-hand corner of the screen, sometimes these markings can get a little complicated and hard to read. In Minnesota, we get the added bonus to deal with the unique northern state issues of marking in the snow and dealing with frozen ground, which is really fun to put flags into. Once the marking is complete, hopefully we have equipment operators running the excavators that are skilled enough to maintain clearance as the locator marks disappear and the trench get dug. Now, if all that seems like a Stone Age process, well, you'd be correct. In fact, there are many issues keeping Minnesota and the nation from properly leveraging GIS and GPS to enhance efficiency and safety when working with buried infrastructure. These issues fall into three main categories: technical, education, and procedures. Let's take some time to look at some of these. In the technical arena, Gopher State 1 call does not have a complete mapped view of Minnesota's buried infrastructure, nor do the utilities. Just because data is in a GIS database doesn't mean it's accurate. And some utilities are still using paper. Fragmentation inside organizations, water versus wastewater, can be two different departments and mapped in systems that don't talk to one another. From an educational front, well, there are no standards for education for locators. A person locating something today that people's lives are dependent on can be done by someone last week who's delivering pizzas. It's largely unknown that the data can be shared electronically without being in a collection with a central repository, an item that's often complained about when discussing the sharing of data. For procedures and standards, there are no standards for capturing, storing, and sharing locate data. Abandoned and unknown distribution lines are not being reported. And then there's liability. There's the hesitancy to share data from the fear of being sued, knowing that nothing is ever 100% correct. So recognizing the problem here, the explanation point on the dimensions of this problem we are dealing with is probably best summed up by this slide. In the upper right-hand corner, you can see a passage from the mapping section of the latest practices issued by the principal industry organization, also known as the Common Ground Alliance. When discussing GIS and GPS and aerial imagery, they clearly tell us that there is not widespread use in damage prevention field. If you turn your attention to the one in the lower left-hand corner in the recent reports provided to Congress in 2017 of the 5 key findings, checking in at number 3 is that the improvement and implement of GPS and GIS technologies in accurately locating and documenting the location of underground facilities. So now to the fun part. So a comprehensive tackle of this situation as described thus far is a series of meetings that went back at least 3 years. In the spring of 2020, the leadership of 2 Minnesota government entities decided to form a collaborative partnership to work on the solutions. Structurally, Barb from Gopher State 1 call maintains operational control, provides the direction and overall guidance to the project team. Naturally, she's able to bring the utility sector to the table. As chair of the Emergency Preparedness Committee of Minnesota Geospatial Advisory Council, Steve provides an administrative home front and support effort, a way to keep, a neutral party to the process that might otherwise be overtaken by product sales and interest. Binding us together is a mutual interest in safety and improving the operation of Minnesota government. This one you pretty much just have to read on the screen, but we have a mission statement. The Underground Utilities Mapping Project Team will work to improve locate efficiencies and accuracy, reduce damage to the state's underground infrastructure, and improve operational and construction safety by leveraging current and emerging GIS technologies through cross-communication, community collaboration, which develops best practices and promotes technology solutions. And although the focus of our efforts is on the underground utility sector, we believe by building better maps for buried infrastructure, we will also be helping several other Minnesota sectors. You can see the ones listed below is just the tip of the iceberg, and anybody dealing with anything with pipes under the ground can put a lot of things in their head as to why better maps will help. We've had an amazing outpour of interest to spearhead this group and get us started. We now stand 35 members strong moving forward. Members are coming from the public sector, the private sector, vendors, media relations, legal, and respondents. These members are primarily out of Minnesota, but not necessarily all out of Minnesota. We have a gentleman from the Canadian border side and got one out of Nebraska, Omaha area. This group here that we're part of, we meet as a large group once a month to discuss business going forward, but then we've also broken down into 4 functional groups where we tackle the project with a little bit more of a focus. These groups include the facility operating utility mapping group led up by Travis. This group, in the simplest terms, is where is the buried stuff? We're focused on how do you map underground infrastructure? What kind of equipment to use? What kind of accuracy standards should we be holding to? What can we actually expect the community as a whole to be able to do? Second group focuses on locate data flows and management. Bob is very involved in this group. And this is a group that, okay, once we figure out how to collect the data, what do we do with that data? How do we organize it? What kind of database? What kind of parameters? And how are we going to set it up so that we can share the data? The third group is our outreach group led by Karen. This is our public relations group, right? This is the group that's going to help, spread the word to people like you for exactly what I'm doing here today, to let everybody know that this is something we're working on and what to look forward to. And then our fourth group is the regulatory security group led up by Dean. This is the legal red tape procedural group, making sure that we're aware of what's out there and how to move forward from a legality standpoint. All right, so in every good presentation, there's a fun wire diagram like this one that you couldn't possibly read any of the words within this or even come close to understanding in the time that I'm going to put it up on the screen. So here's ours. What I want you to take away from this is that the core of our efforts that we're working to is identify a sequential procedural step, and that for each step we identify the existing hurdles and identify if these hurdles are going to fall into a technical, educational, or procedural bucket. And to move forward, we're going to have documentation and take this as a process. And then in no better spot to put in this presentation, I like to throw this one up here. I think it really hits home, but locating utilities should use location-based services, not paper and spray paint. So moving on, as discussed in the very beginning, we're going to talk about some of these pipeline threats, why this is important. Got 4 different categories here too. First up is bad geographic information system data, or not really knowing what you have in the ground. The poster child for this category is a gas pipeline explosion that took place in California in 2010. The essence of this event was Pacific Gas and Electric boosted their delivery pressure in a gas delivery pipe to meet demand, and thereby created an explosion in a residential neighborhood, resulting in 8 deaths, 500 impacted people, and lawsuits exceeding $600 million. And the lawsuits and the litigation are still going forward with possibly with an excess of $4 billion. All this was caused by a decision to boost pressure using GIS data, which was faulty. So again, just because it's electronic data doesn't mean that it's correct and good data. Checking in as threat number 2. I'm not going to go into a lot of details about each one of these individual events. Regrettably, they've all happened and lots of lives have been lost. But this has to do with just human error, an error from the locator, an error from an excavator. And number 3, we have construction hits on abandoned pipe. This example here in 2017, 2 men were killed and a woman was seriously injured, was from a gas leaking from a damaged, abandoned natural gas collection line that blew up in Colorado. Between fines and the undisclosed settlement, this one came in at probably somewhere north of $60 million, all due to an abandoned pipe the city forgot to tell the residents about. Unfortunately, as in other industries, there's a mantra that rules are written in blood. This event prompted a flurry of legislative activity in Colorado to keep a similar event from happening in the future. The 4th and last point of consideration with regard to pipeline threats is structural failure. Again, I chose my picture in the background here on purpose, kind of hitting home on this one. Anything built by humans is eventually going to fail due to aging, pre-existing conditions, damage, poor installation, the list goes on. And then given that some of our buried items are now approaching 150 years in the ground, this one might be worth keeping in mind in the back of your head. And then a couple of these examples here, most of you are probably not familiar that the largest inland oil spill in US history actually happened here in Minnesota in 1991, where an oil line ruptured near Grand Rapids, spilled 1.7 million gallons of crude oil onto the Prairie River, where by a grace of God, the river was still frozen, a stroke of luck that facilitated a cleanup that would probably still be going on today if this had happened when the river was open and flowing. And then we got another example here that I won't, for essence of time, won't go into detail, but another major inland oil spill there. When it comes to petroleum pipes, you guys have probably all played in ESRI's Living Atlas and clicked on the layers, but it is a spider web of pipes. They are everywhere, and there is lots of them. And Minnesota is not unique in that fashion. One of the things that I want to spend a second here on our timeline pointing out is the 3rd on the list here is that pipes running from a local provider to the product end user in this category, it's the Wild West. There were no rules about recording the location, specs, and etc. of anything abandoned before 1998. Consequently, it is why even decades later, install crews are finding abandoned and unmarked pipelines, which pose unknown risk. And remember, there is no requirement to report these systems when crews come across them. So it's kind of scary. Kind of just hitting home on this.
Get about 5 minutes left.
All right, hitting home on this. Again, a lot of this is not an old problem. This is still a new problem, or a continuing problem. We're still hitting these pipelines at an alarming rate, causing millions of dollars of property damage. For last thought on Minnesota pipes, I'm going to leave you with the last big one. It was in 1998. It's in St. Cloud that a natural gas delivery pipeline was hit installing a fiber line, resulting in 4 deaths, serious injury, 10 minor injuries, and 6 buildings that were destroyed. The big event may be more than 2 decades in the past, but if we don't get better maps into the field, it'll happen again. So what are, one of the things that our group does that as we meet monthly and weekly with our small groups is we try not to reinvent the wheel. As I said earlier, other parts of the world are ahead of us. So we are working with presentations and research into other groups out in Europe on what they've been doing to help us with coming up with recommendations. We also are communicating with a lot of different vendors with equipment that can help us understand what's available, and other states that are a little bit more proactive than even us in Minnesota would like to, think that we're the best. But Colorado and Montana are working with their industries on a higher level than we currently are at the moment. So we're seeing how they're doing things. And then, I talked about this a little bit earlier. In 2020, we started this group. We kind of got the ball rolling. We got organized, defining scope, mission statements. 2021, we've continued our research. We've talked to a lot of people, had a lot of presentations from people to us to help us with our research. We've started some best practices. We've kicked off a couple pilot programs for new locate technology and sharing data models. 2022, we're going to continue that, hopefully get to some best practices that can be released, have some national conferences, get feedback, bring it back to the team. And then 2023 and beyond, hoping to really get this moving in the right direction. And I wanted to save a few minutes for Bob, but our goal is that the slide that you saw earlier, that I unfortunately can tell you is not the case. Everything from a technology standpoint is available for us to have this be the case today. We just hope to move forward to get there. And final thought is, I'll let you guys read this as I introduce Bob, but what's some of this stuff worth to us? Hard to put a price on. Bob, you want to talk a little bit about the pilot stuff?
Well, yeah, we got a couple of projects that are just starting up. We just got the okay to start one a couple of weeks ago. But the projects are kind of focused around introducing a digital data transfer and usage so we can share the data for different reasons. The big one obviously is the Gopher State 1 call. But in doing some of our discussions, we've also identified another, not necessarily a critical need, but it is a need that has actually been percolating under everybody's kind of perceptions for a while, in that when you're doing preliminary design, and I'm looking at this from a municipal perspective, our engineers need to be able to see the same kind of data when they're building projects. So having a mechanism where we can share the data and be able to move it back and forth between the asset owners and the people that are actually designing new projects is going to be a big boon. Okay. So those are the kinds of problems that we're planning on solving with the projects and the things that are in development.
Yeah, and then Gopher State 1 call is supporting a demo of some new locate technology that can shoot GPS points in with the locate, and also talk to the SONs in push camera and CCTV and technology. And with that, if there's any questions, moderator, we can get to that.
Awesome. Thank you, guys. So yeah, if you had any questions, put them in the Q&A board. So doesn't look like any initial questions right away. So I kind of wanted to ask. Oh wait, we do have one. We do have one.
Hey.
Jonathan Brasky asks, what are some more long-term goals for the team?
Long term, we want to put together some white paper with best practices, recommendations that we can bring to regulators to put procedures to the stuff that right now has no procedures. And we're hoping that as a unique group, that's come together as a bunch of volunteers of industry experts on working on through this process, that it can be something that can be applied to not only Minnesota, but nationwide, to ultimately have better maps, better data sharing to lead to safety and reduce cost of construction projects.
Cool, thank you. A question that I had has to do with the accuracy in the mapping. Is I had a buddy who worked for a city, and they had underground GPS tracking tech, but they weren't allowed to say that, like, to give it out because of accuracy issues. Right. So what is the accuracy that people want to have?
Well, I mean, within a bucket scoop typically, right? But better the better the better, right? But it kind of dovetails back into what I touched on earlier, which is one of the hurdles today is the liability part, right? It's breaking through the boundaries of sharing without the fear of the being sued if it's maybe 2 bucket scoops or the wrong side of the street or a human error. That's one of the hurdles that we're working on breaking, because we got to get through the sharing, the sharing part.
It is one of the aspects that is talked about quite a bit while we've been developing things. So as we've been moving forward over the last year, that particular topic comes up quite a bit.
Right. That's one of the reasons that one of our group is focused on legal, not just GPS and mapping.
Cool.
If anybody's interested in a little bit more detail about how some of this pieces might work, I did a presentation from a municipal perspective yesterday. When the recordings come out, you might want to take a look at that. But I get into kind of the details of how things would functionally be managed with the sharing of data from a municipal perspective, which would, it would play over into anybody that owns anything underground. But my focus on the presentation was from the city's perspective.
What was the name of that presentation?
Oh man, now you're putting me on the spot. Just look up Bob Basques.
Okay, thank you.
I was underground utility, city perspective.
Thank you very much.
Sure.
Well, another question. I know some cities map out just certain utilities. Would some energy companies be on board with this too? For example, Xcel Energy.
And that's why it kind of goes into the last one. I mean, it's that sharing data thing again, right? That's, as Bob said, it's probably our most common discussions that we have as a group is how to break down those barriers, how to develop, like what Bob's start working on is a way to share data without being in a central repository, to be carved out and given to stakeholders, on an as-needed basis, with the right legal jargon for cover the liability of people's butts.
Yeah, the mandates are there for people to actually mark their assets underground. So that part of it is already something that is as an enforceable item. What's not enforced is the digital data sharing, and that's the thing that we're going to have an uphill climb with. Everybody contribute.
Right. I mean, Xcel Energy is there. Trust me, they have plenty of GIS, problems. And I can tell you, even as working for a contractor, when we bid work for them, they have an entire page questionnaire on what our GIS capabilities are, so that we can help them with that as it's being installed or worked on. So the data, yeah, they're collecting data, but it's just the sharing. And then making sure we're, again, putting best practices and procedures together so that, you know, we got apples and apples.
Awesome. Well, that's kind of the end for the Q&A time for you guys. Thank you,
Perfect.
Damon. Thank you, Bob. So then now we go on to the final presenter. We got Michael with advancements in subsurface utility engineering and mapping.
There we go. Thanks, everyone. My name is Mike Picha. I'm a licensed land surveyor. I've been working with T2 utility engineers for about 5 years now. We're based out of Fridley, Minnesota. We have offices all over the US and Canada, about 35 of them. We're in the business, we do subsurface utility engineering. It's a little bit along the same lines of what Damon and Bob were just talking about. Certainly respect our friends over at Gopher State One Call and everything they do to protect facilities. Our efforts are typically more focused on assisting designers for specific projects. Many of them are transportation related, but certainly not limited to working just with roads. To be kind of clear, as we're talking about kind of what we were just talking about and kind of what we do for the projects we're hired to do, we don't rely on any of the one call services or any of the owners to locate, do the field locates. We use our own staff for all of those things. With that, I'll go ahead and jump into it here. Quick review, kind of a little bit of subsurface utility engineering, which we affectionately call SU. Back in the early 80s that, you know, the old ways of designing roads and kind of plowing through everything that was there and not taking any consideration certainly was a problem. So SU started getting developed. 1985 was the first statewide SU contract in Virginia with their DOT to do SU type work. It was just a year later that also utility coordination was included in with those contracts that, you know, a firm like ours, we have utility coordinators that work as that third party to make those contact with the utility owners to get the information, to make sure they understand the projects that are upcoming, what's going on with the projects and types of things that can be impacted with that. In 91, Federal Highways began promoting it. In 2002, which I'll talk about a little bit here, is with the standard, the ASC 3802 was adopted by the Society of Civil Engineers. And that is the guidebook that we work off of and follow for all the work that we do and guides us for the standards that we set for the work that we do. With 2018, there were 38 states that have adopted SU and have SU contracts within their districts, either statewide, city, region, things of that nature. There is, as you can imagine, since 2002, a lot has changed. So we're expecting an update maybe by the end of this year or into 2022, which will have a lot, as I said, a lot more updated information on that we're looking forward to seeing. We've kind of seen a little bit of what's coming on it, but we're looking forward to getting our hands on it and being able to apply it. So 3802 is a consistent standard guideline for collecting and depicting the existing facilities. So it's a national standard that is used, widely used, that everybody understands and can accept. And really what it does is it creates a common language between all the owners, the facility owners, the designers, us as SU professionals, or the owners of the project, to be able to understand really when they're looking at data on paper and they're designing, you know, their projects, is what kind of reliability the data that they're looking at has. They can, you know, decide based on the reliability of that data if more information is needed, those types of things. So such a classification will allow for the project owner, engineer, constructor, utility owner to develop strategies. And really, this is all about reducing risk. Just as we're talking about, we certainly want to make sure that, you know, there aren't any accidents. You know, it's some of the terrible things that can happen with these types of projects at the facilities that are certainly in the ground and below our feet is really important to understand. And certainly the cost saving that can go with that too, with having good data of where it is, and certainly trying to design and build roads, or, you know, redesign roads around these things to really to get things done in the safest and cost-effective manner. So what is subsurface utility engineering talking about this? Really the quality levels they have on this with the standard, break this down into 4 quality levels: quality level D, C, B, and A. It's kind of an interpretative science, therefore a skilled team with knowledge and construction history and years of experience sets us kind of apart for what we do. And I'll go through each one of these to kind of identify what exactly we're talking about here. So the quality levels, really, it's a professional opinion of the quality and reliability of the utility information. So the reliability is determined by the means and methods of the professional. Typically they're cumulative, starting at D and working your way up to A, but they don't have to be. And certainly, as I said, each standard is defined, each quality level is defined in the standard. So quality level D, which is the lowest form here that we have, is really just any existing utility records. It's information derived from existing records or oil regulations. Certainly, the person that's been working at the city since, back in the early 80s, they might remember when something was put in the ground, they really don't have good records for what there. We certainly can work with them to try to get some more information, or, from the typical means that we would get to any of their drawings. Anything else, we use one call for records requested, things of that nature, to get those as well. And then we certainly follow up with utility owners to try to get as much information as we can, not only in records they might have, GIS, paper copies, but any as-built construction drawings, any of those things, to really try to get a complete picture of anything that's underground. As we move up to quality level C, it's really kind of the use of the above ground surface features. As we start to kind of put these together, we can reconcile this information with the quality level D record data that we have. We can start kind of seeing the structures. We can start connecting those dots, and we can survey those as well. When you think in terms, especially like with sewers, where you have inverts in, each one of these structures and things, so we can start to identify those and measure those and start getting ideas of which way things flow in that nature. But you don't want to forget about everything else that's out there as well. And of course, we're reconciling that information with the record data that we have to see if it all makes sense. Is there anything missing? And you really start kind of looking at that. You certainly want to make sure to keep your eyes up as well. You have the picture on the right there. There's, there's cameras on there. There's Wi-Fi boosters. There's all sorts of other things to consider when we're going through these projects, to identify and make sure we're accurately mapping them, and making sure we're getting a hold of the appropriate facility owners as well to make sure that they're in the loop on these projects, and they're in the discussions for the design and potential impacts to their facilities, and how we can try to mitigate these, and the steps that'll need to be taken with those as well. So quality level B, this is the designating or locating. We kind of have the slide in here. So typically with the one call I hear a lot is a lot of the locating, the field locates, and pursue. The terms are kind of flipped a little bit, so I put it in here. So we typically call it designating. It's the process of using the geophysical method or methods to interpret the presence of the subsurface utility and to mark its horizontal positions. So it's designation on the ground surface. We have many types of equipment that we use on here. Certainly, we're not limited. There's more on here, but we certainly have a lot in our toolbox to use, depending on what we're trying to do and try to identify and try to locate within the ground as well. There's certainly no lack of utilities, especially in highly urban areas and things in the age of these as well. So it's important to make sure that we have a wide array of equipment that we can use to try to identify anything that is under our feet. One of the things that we do as well is we create utility point sheets and sketches. One of the problems that with a lot of consultants and firms that we work with is, the process would be to go for state one call ticket, you go out, and then they have the surveyors pick up the marks. Sometimes they can get pretty congested, as some of the pictures that we saw earlier can show. So what we do as well is we have a point sheet and a sketch as well of all the work that we do. The sheet references any paint marks or anything that have been put on the ground. So each mark has its own identifiable number, or we have also a lettering system that we use as well with them as well. So if it's us doing the survey, or if we have another sub-consultant surveyor on board, they can follow the list, the point sketch list that we have here. And we also have a field sketch of everything that we've marked. So they can follow that as well to make sure that everything was properly picked up as we put it on the ground. and they can use it as that. So you can kind of see on here, like for instance, we have an electric line. So we start with a line, it's E1, E2, each one of these is a line. How many points are put on the ground? You know, if it's a gas line, an unknown line, water lines, things of that nature, kind of follow that process as we go through that to make sure everything is properly picked up and identified as it's put into the data collector for further processing in the office. So certainly, you know, there are some differences between for what we're doing and what one call. Certainly, I, you know, or go for our friends that go for say one call. You know, they have a you know, a job to do, and it's certainly so the information received really has no guarantee of accuracy, as we talked about. You know, within a bucket scoop or a couple bucket scoops, or you know, see the picture on the right. It's typically something that we typically see. That's we did a test hole there. You can kind of see the differences in the paint on the ground of where we found the utility and where the previous marks were set by somebody else on there. It's pretty typical of what we see, but then again, you know, for damage prevention, it's probably good, but you know, for some of the design things that are going on, if you're installing new manholes and catch basins and things, you know, sometimes require a little bit more of an accuracy. So that's what we do. The one call locators usually has a single utility focus and limited by time. You know, for our process that we're doing an entire corridor within there. So we're not only looking for specific utilities, but we're looking for, first of all, we have all the records that we try to get all the records. We have all the records when we're out there doing our designating and everything in the ground. But so the, we also perform utility sweeps out here as well. So we're looking for unknown, any anomalies out there, anything that we might be records of out there. So there's inductive and conductive sweeping that we do out there as well that we can look for. Again, there's no point sheet or sketch for accuracy. So technically the survey of one call paint marks is not quality level B. It really comes down to the utility data records and interpretations and the designation. They're not performed under the responsible charges of a registered professional, and therefore don't meet the standards of ASC 3802 as well. So quality level A locating is really the next level that we have, that once we get into certain projects we usually go through, we'll do all the designating, we'll map this out, which I'll show on the next slide of kind of what that looks like. Is we can do precise exposure of the utility on there. We have our own equipment, we use air. I understand that there's water as well that you can use, but we use air with ours. It's minimal intrusive excavation method that does not damage the facility itself. And typically these areas are identified, and once the design usually gets to about 30%, we start identifying conflict areas within the corridor. So we can go out there and we can identify the exact XYZ location of these to determine whether or not these are actually going to be in conflict. If they can get moved, you know, sometimes we do it for verifying size because records are not all that great. So this is done to the survey grade accuracy. And then again, is supported by the quality level D, C, and B information as well. So here's an example of some of the work that we do when we compile all this information. As you can see here, we have, there's a water line that's metallic is coming across here. We have all sorts of communication over here. We got RVIG, CenturyLink, which is now lumens in here as well. We've got some transmission lines. You can see here, we've done some test holes on some of the gas. We put all this information in here. This is a PDF of the plan sheet. We would deliver these typically in Bentley or MicroStation or AutoCAD drawing. So the designers can put this information into their design and overlay it right on their layout and while they're designing. So as you can see, it's in here as well. We also have sanitary sewer, storm sewers. We got some culverts that are running through here. All the information of everything that's in here is we depict this on all of this. So it is going out into the field. We're collecting the data and then we're delivering all this to the client. So another thing that we talked a little bit, the previous slide I had, there's not a whole lot of time here to get into a lot of the advanced geophysics, but with the ground penetrating radars. So what this is showing here is for some areas, typically highly urban areas, you know, Minneapolis, St. Paul, some of those other areas, we can get a higher level of detail. You know, there's a lot of history below our feet. There's a lot of records that have been lost. There's a lot of things that have been paved over. As you can see here, as we're kind of scanning through down the different depths, as you can come here, you can see some of the manholes coming out here, see some of the store lines. Maybe there's some ducts that come through here. We can even see trenches as well where the soil's been disturbed as we come through here. But so what we can do if the project warrants it, not all of our projects would do this, is we can kind of overlay what we've done for the quality level B designating and everything else, that we can overlay that right on the top of here and really start seeing if there are any anomalies in here that would warrant further investigation to see if there's something else that we couldn't see using these other methods, and investigate it further that way. So it's pretty exciting. It's certainly another tool that could be very useful as well. I know we just did a project in Minneapolis that we did the GPR on right here, and there were some railroad tracks that were going under the road that were an old abandoned railroad line that they didn't even know existed. So it was very helpful for them as well to know that that's there, and that as soon as they do put the shovels in the ground, that they're going to have to deal with it. So get a little bit in here into 3D modeling. This is becoming more and more, we're seeing it more and more, certainly as the corridors continue to get more congested. The importance of reliable and accurate information will increase, as well as the use of these models, as well as utility coordination and making sure that there's a good channel of communication is going to be increasingly getting important, especially when we're coming down to schedules and timelines. And when contractors, construction contractors, people are putting bids on these projects, and having to do scope amendments and things on the back end, it certainly takes a lot of time. It's a lot of extra unanticipated money. So certainly getting all the information as soon as early in the possible in the process, and getting the utility owners on board and get them informed of what's going on with these projects. You know, especially when you get into areas of high relocation times. I mean, high power transmission lines certainly can take a long time to get those things moving, especially when you're looking at ducts. CenturyLink Lumen is a big one that's notorious, that certainly once we get started on these projects, to get them to move these can be a big deal. So this is a project we did in 2018. If anybody's been through Minneapolis lately, you'll see this 3rd Avenue Bridge in Minneapolis is currently under construction. We did the SHU on this. There were some concerns about the approaches. There's going to be some new grading on the approaches. They were concerned about some temporary crane platforms, spud locations for any river barges with cranes and things of that nature. So we went out here and we did the SHU on this project, and we did this to the 3D model. What you'll be able to see here as we get into it is we have some above ground LiDAR overlaid on top of our 3D SHU file as we're running through here. So all the color standards and everything as you're looking through here, the gas is yellow. This 36-inch water line is blue. Communications will be orange, power is red, things of that nature as we're kind of running through here. This was really exciting. Some of the things that we did is we used LiDAR, and we used it on an inverted tripod, and we actually scanned some of the manholes underneath the ground here. So as you can see, we have this standard manhole that we have here based off records, and we have this one here. You can see the point cloud within this drawing here as well. All of this information is contained within the deliverable drawing that we give for the designers to have at their hands. You can see here this other intersection. You have another water main that's coming. It's tucked underneath here. We have it encased and things of that nature. It's pretty exciting, some of the things that we can see and things that we can do. Certainly you can see the brick patterns on the inside of this chamber here. Certainly a lot of things to relay. Of course, this is the interior dimensions of the wall, so it's not factoring the thickness of there, any shoring that might be on the outside of these as well. Look right here, you see these targets right here. These are locations and how we identify where we've done test holes within the project as well. So this 36-inch water main comes down here and it tucks underneath the abutment of the bridge here. This right here, as it's coming out here, was a big concern as well for MnDOT, along with his water, is understanding there's a 30-way duct package that Lumen owns that does get tucked up underneath this bridge. And that was certainly a big part of this project as well. So as we come down here, it tucks underneath the abutment. There's an old railroad bed here that is encased. And then the water gets sucked up and tucked underneath the bridge here. And they both are going up underneath here. One of the things we did as well is we scanned the inside of this pier wall that we'll be zooming in here too, which is pretty incredible, the detail and the information that we're able to get at the fingertips of the designers to actually see what's inside of here and actually have a 3D model of what's in here with this point cloud and all the facilities that are inside of it. It was pretty exciting. It was a really fun work, and I know we received a lot of really good feedback from the project, the owners, and the construction contractor as well for a lot of this work and how it was beneficial for the project. So I'll briefly kind of get into a little bit of what is a 3D model. And so really the first step in the 3D model is to start with the good quality level B data in the SU drawing. We start that. That's the basis of everything that we do when we interpret, and we start putting depths into here. So we really want to take any depth information that we've gathered during the investigation to kind of create our 3D model. So really it's clear that it is a representation. Of course, it's very important to understand its theoretical representation and some of the points of the buried underground infrastructure. So the depth is being added to the model from our SU drawing or 2D SU drawing. And the depths are based on physical measurements, assumed depths, and records. It's not always apparent where that depth information came from, so it's really the biggest struggle we have with 3D models. So really it's a blend of these verified data points and test hole or invert measurements. So really it's a blend of these assumed depths. It's really important that the end user really understands that the assumptions we take and build during the 3D model, that they need to be stated, and that it becomes difficult because sometimes those assumptions or statements can sometimes get separated from the physical file once we deliver it. So we truly try to make that clear and concise what assumptions are made when these types of things are delivered. So we have something called what is a technical memo that really understands that, if there are assumed depths on a lot of the gas and a lot of the water that down there, whatever MnDOT standard is, whether it's 7.5 feet or 3 feet, or if it's 5 feet underneath the roadway, that's what we're interpreting in here if we did not do a test hole or we don't have invert measurements on there.
Got about less than 5 minutes.
So I'll finish here. This is the, kind of the benefits that we're seeing from a 3D model. The 3D model projects have typically been created for larger linear projects from a lot of what we've seen, but they're not always limited to these large linear projects. What we're looking at here is through Elk River. This is Trunk Highway 169. Currently, it's a two-lane highway, separated highway right now with stoplight interchanges. We'll be moving it to a 4-grade separated interchanges. Thankfully, I don't have to do this commute right now, but it's going to be really nice when it's all done. So these will not be limited to what we're seeing is not limited to large projects or entire corridors as well. We're working on another project here where we'll be doing kind of the same. They'll be doing the highway and adding some grade separated interchanges. And we'll be focusing our efforts kind of on the grade separated interchange portions with the 3D model as well. If the project will be designed with a 3D model as well is where we'll see these requests, whether it's sometimes if we're doing work for MnDOT, they'll be doing their own design, or sometimes they'll hire the consultant to do the design. They know it's going 3D. We're seeing these coming here as well. So this model here, you can see from the slide, is a model that was developed by one of MnDOT's consultants, WSB. This model really incorporates our 3D SU model and all of the line work that we did based off that. And there was about 300,000 linear feet of utilities, where obviously utility coordination has played a huge part in this to ensure that the projects are delivered on time and within budget. One of the many unique features of this platform is also the ability to run clash detection software within the model to quickly identify these conflict areas and really get inside the corridor and see how they all tie together. So it's really an ease of conflict identification. Another big thing we're really seeing here is accessibility as another huge advancement here. With AutoCAD and Bentley, they have online viewers now that allow really anyone to access these models. With an online viewer, it means you really don't need to have the software on your computer to view and drive in the model, and you can do it from an online platform. So thinking in terms outside the project teams, now even utility companies can easily access this technology when creating relocation plans and things of that nature. One of the comments, I kind of finish it up here. One of the comments that we had from one of the project managers that we have is really the beauty of the 3D that they like is the comfortable user interface to consume it. It's historically unable to do so easily, and clients are finding it much more intuitive. I don't know if anybody's traveled to Nepal lately, but figuring out this relocation plan could be a little bit of a nightmare. And with that, if anybody has any questions, I'd be happy to take any questions.
I know we have a question right away from Bob, which is, have you thought about using LiDAR as a mechanism for building out as builds for your projects?
We have. It's not something that we have. It is still going to be, I think, a lot of field verification that's going to go along with the LiDAR. Then again, I think it comes down to you're going to, as far as what kind of guarantees of accuracy have, with the deliverers that we are stamping them with a licensed engineer. So I think there's certainly some benefit to that. I think for the application we have, like the LiDAR that we had in the video that I showed, that was provided by the consultant who had done that. But it certainly fits great with what we did. But I certainly think that it can be useful, and it's certainly not something that we don't have our radar on and kind of keep an eye on, but we're just kind of waiting for that technology more to be developed and see how we can apply it. That's really going to enhance the process that we have better than the kind of the way that we're doing it now. Certainly it has a place. I agree.
So you guys don't do any LiDAR related stuff. All of that is usually gathered by somebody else, or do you occasionally do your own collection?
We have offices that do. Actually, some of our offices are more survey focused than SU focused, and they do a lot of scanning with LiDAR. They have drones and things of that nature, but it's not something we typically do out of this office. No. I appreciate everybody's time. Thank you.
All right. Well, it sounds like that's going to conclude everything for this session then. I'd like to thank our presenters who decided to come today. Thank you very much for attending. And I'd like to thank all the participants for coming as well. And I hope that everybody had a good conference. Thank you very much, and everyone have a good weekend. Happy Halloween.